Alright, let's look at the homework 17, problem number 10. Alright, so we want to evaluate this double integral over the surface of a hemisphere. And the v is y comma xz comma 2z minus 1. Alright, so in order to use the divergence theorem, I'm going to actually add another surface so that we can apply divergence theorem. So let's say I'm going to call this hemisphere H. So this is going to be a double integral over H, right? So H is this hemisphere right here. All right. So this is our H, right? Then I'm going to add the base B. So the base is the circular base here. And the radius is, since it's 9, so it's going to be 3. Right? So that's going to be our base B. Right? So we know that the double integral over this hemisphere H of v dot n and d sigma, and combined with the bottom side, so it's over b, right? So same thing, v dotted with it's actually, we know this one because this one outer normal vector is negative k. Right, so we can put the negative k there. Right, the sigma here. Right, so this is the on the boundary. So if you call this hemisphere with the inside or half of the ball is a triple integral over the ball, I'm going to call this guy tau. Right, so the boundary of tau is hemisphere and combined with the base B. Alright, so it's going to be a divergence of the V with respect to this is the volume element. Alright, so keep in mind that what you're looking for is this guy. Alright, so what you can do is I'm going to put this guy over to the other side, right? So that way we're going to get what we're looking for. So integral over this hemisphere v dot n is going to be equal to, right? So triple integral over the half ball. All right, so let's take the gradient of this this guy right here. So partial with respect to y is 0, plus partial of xz with respect to y is 0 again, plus partial of 2z minus 1 with respect to z is 2. Right, so d tau. Right, and a minus, right, then you have double integral over the base b. Alright, so so negative k is 0, 0, negative 1. If you dot product with the y, xz, 2z minus 1 is just going to be negative 2z plus 1. So it's going to be 1 minus 2z, right, the sigma. Alright, but know that on base B, z value is actually 0, so this guy is actually 0. Right? Then what you get is going to be here. We know this guy. This guy is 2 times the volume, so 2 times the volume of tau. Alright, this guy is integrating 1, so it's going to be the area of the base B. Alright, so I'll let you guys find this guy and find this guy and do the find the difference. That's going to be the value of the integral that we're interested in. Alright, that's it. I hope that this will get you guys going.